Okay, folks, we'll go ahead and get started. And what I want to do today is cover what I would consider the fundamentals of normalized databases. And so databases that go through a process called normalization. It's kind of an intimidating term when I first learned it because people were using the term and I didn't understand what it meant to be a normalized database. But as I learned that normalization is a process of a series of steps, if you will, to end up with a database design that is efficient in terms of how you're storing the data. So when you hear the term normalization, just realize it's a process, it's a series of steps to take to store your data in an efficient manner. Now, if you remember a little bit from last semester, you remember that normalized databases have been the standard for a long, long time. Okay, and I'm just spitballing, I want to say 50 plus years. There have been normalized databases in IT systems, right? Well before the internet, there were normalized databases. And before these normalized databases, there were spreadsheets. And before spreadsheets, there were just files, digital files, right? So that's kind of the evolution of data storage. Data storage went from single files into something like an Excel spreadsheet that would organize the data and still in single files. And then we got into this concept of normalized databases, which the one true advantage of normalized databases is that you're not storing data redundantly, okay? And it's really good at not having various problems or what are called data anomalies. Okay, and so normalized databases have been around for a long time because they're really good at avoiding common problems with the data. And so we're just going to learn this. Now, since databases have been normalized after that, of course, they have NoSQL databases like Mongo that we learned all about last semester. So after normalized databases came NoSQL databases like Mongo and others. Okay, but certainly normalized databases are still out there. In fact, let's ask I call it ChatGPT. I'm going to ask Microsoft Copilot, which is kind of funny. I just want to show you guys this. If you just open up Edge, question for you. I open up Microsoft Edge, and over in my taskbar, I now have a Copilot, this is Microsoft's AI, and it can actually, it's a chat GPT, it's a GPT, if you will. Okay, this is Microsoft's GPT, and it's built right into Edge, so I find that fairly convenient, even though it's not chat GPT, because it is ultimately Microsoft Copilot, and whatever OpenAI was bought out by Microsoft. So I'm not sure how much behind the scenes here at ChatGPT. Anyways, the question is, what percentage of databases today are normalized versus NoSQL? And we'll kind of see what it resolves to. But the point is, according to one source, it's about a 60-40 split. Okay, so even though, just according to this little one reference, even though I would make the case myself, my personal preference, my opinion is that I like NoSQL databases more. They're newer and they offer a lot of advantages. Out in the workforce, it's still, apparent to me that you should probably know both. Okay, so let's go through these basics. Now, what I want to kind of to start off doing is I'm on Lucid Chart. This is just a website, lucid.app, and I want to make a real quick diagram of a simple. So what we're going to do today is we're going to make a very simple database, 2 or 3 tables, okay, and it's going to allow me to explain a lot of these basic concepts. Okay, and what I want to start off with is with a little UML diagram to basically show what I want to build. Now, there's a whole lot going on here. And I guess that's the problem with starting with the template is I don't need all of this. I do want something like this line, and so there's relationships that I ultimately want to show. But what I'm going to build here, and this is going to be kind of rough, but what I want to build is a database to have students and their relationship to, because you guys are all in class. Let me pull up another class here. And there we go. UML class. Okay, okay. Go away. And courses. Like a student would enroll in a course, right? And so the reason I want to show this relationship is because of a couple of things. And so we're going to have entities. And so the first thing, I personally, when it comes to database design, okay, it is a process of designing the tables in your database and how you're going to store the data. And I personally have been told, I remember like in my database class, there are full classes on database design, okay? And I will say in my academic career, it was like one of the ones that I struggled the most with. The reason I say that database design is not something that's come super easy to me. However, I've learned a lot and I can share that with you. And so what I want to talk about is relationships between students and courses. Now, one of the first things that you learn about design is, okay, what goes as a class? And I talked about this a little bit yesterday. These entities are your nouns, right? So you got to think of your English class, your people, places, things, and events, right? So a student is a person, a course is a thing, right? So any noun can be an entity in your database that you want to store data about. So normally when you're going through this process of database design, you start off with a description of the problem domain. In other words, what is the problem you're trying to solve? And you write it down in like a paragraph format. And then what you do is you extract the nouns. You literally look at the paragraph and you say, what are the nouns? And these are all the potential entities on your UML diagram. We didn't have this written problem. This is just a standard problem to solve, which is that of like a learning management system, like an Inside Rankin. You have students and courses. It's a simple demonstration. But that's why I want to talk about, first off, what are the things that go in these boxes? Well, they're nouns. And those are nouns that are in a problem. And if you have a written problem, you might have 100 nouns or 30 nouns. That doesn't mean that all of them have to be documented in your diagram, but they could be. Okay? So the next thing that you're going to do is this little line right here. And this line is known as cardinality. It's kind of a fun word. Cardinality simply needs to show the relationship between these entities. Okay? And I'm going to describe why this cardinality is very important. Okay? So if you stop and think about it, students and courses, what's the relationship between the two? You have to ask two questions. What's the relationship between a student to a course? And then what is the relationship for a course to a student? So like it's a two-way street. You have to ask it both questions, both ways. Okay? So if you're answering that, if you begin to answer that, what's the relationship between the student and the course? You would say that one student could enroll in many courses, right? That just makes sense. One student could enroll in many courses. And if you ask the question the other way around, one course could have many students. One course could have many students. So you have a one-to-many relationship on both sides of the street. You have a one-to-many on both sides of the street, which wind up when you say, okay, this entity is one-to-many, and going the other way is a one-to-many. In effect, what you have is referred to as a many-to-many relationship. One student can have many courses. One course can have many students. That is the definition of a many-to-many relationship. So, again, just kind of, it's pretty simple. You have one-to-one relationships, you have one-to-many relationships, and you have many-to-many relationships. And so if I say list the types of cardinality in database design, you should get those answers and maybe even a few more. But there you go. You have a one-to-one relationship between entities, you have a one-to-many relationship, and you have a many-to-many relationship. Okay? And those are dictated in this diagram by these little symbols. Okay? And it's a confusing notation because there's a couple ways of dictating that. You could dictate it with numbers and stars. Or there's another notation called crow's foot notation. In other words, there's many ways that you could draw this relationship, that you could draw the cardinality. But you could say something like one-to-many going one way, and one-to-many going the other way. So the way that I typically draw it is with, it's called crow's foot notation. And I'll draw it on the board here, and this isn't going to be any good because I don't know how to draw this in Lucidchart. Okay, that is referred to as crow's foot notation because these look like crow's feet. Okay, so you say one-to-many going one way and one-to-many going the other way. So again, it kind of shows the two directions of the street. And so I jump right to the many-to-many relationship because it's special. Okay, many-to-many relationships are special, and I don't know how I might dictate that with, I maybe say one-to-many going one way, and maybe you would say one-to-many going the other way. If I could type in that box, one-to-many, one-to-many, something like. But the point is in this diagram is that this symbols need to communicate that this is a many-to-many relationship. Okay, one-to-one relationships are cool; those are easy in a normalized database. A simple one-to-many relationship, that's easy. It's not until you get to this many-to-many relationship that's something that you have to fix. Normalized databases do not efficiently work with many-to-manys. When you're in design, you have to introduce a new table. Okay, so anytime you have a many-to-many relationship between things, okay, in this normalization process, you have to introduce, that's a problem to fix. Okay, it's not considered good design to have many-to-manys. Okay, and that's like the quick version of it. We can get into more details as we go through. But that's the quick version of it. Now, students, maybe I draw this because this class, if I were to say that this is my student, well, now we're talking because now we're going to start talking about the attributes of a student. Our attributes, these are our fields. This is our data. So a typical UML diagram, you put the entity up at the top, you put attributes or your data after that, and then you put methods after that. Okay, now here's what I'm going to talk about students. I might do a private field, which is dictated by a minus sign. Okay, and if I kind of, you could see the convention here. The access modifier is first. The identifier is next, followed by a colon, followed by the data type, right? So UML, again, this is a diagramming tool for communication purposes. The whole point of UML diagrams is to communicate database design. So our fields in object-oriented programming, you want to data hide your fields. If you guys remember, hiding your data is kind of like one of those principles of object-oriented programming. You want to hide your data, so I'm going to mark them as private. I'm going to have my identifier as underscore student ID, and its data type is an int. Right? And once you get that down, you can say, well, I want a private field, and I'll just say student. Again, we kind of given name is a string, and maybe because this is a student, you could even make this more condensed. You could just say underscore ID. We already know it's a student. We could just call this given name as a string, and I'll say private underscore family name is also a string. Okay, now I'm not super concerned right now about the methods of our student class, but we're just going to keep this really quick and simple. So I talked about what an entity is in a database diagram, which, by the way, we're going to be creating this. We're going to create this simple database. Okay, I talked about what is an entity. I talked about types of cardinality. I talked about many-to relationships need to be broken up. Right? You got to break up many-to-many relationships. But before I really talked about many-to-many relationships, I maybe should have started here. Okay? What is it called? What is this ID? This is going to be a special column. Right? Anyone remember in this normalized database kind of thing what we call this ID column? It is a key. There's one word in front of that. Primary. Okay? So if you guys are following along, wake up. This is very important. Right? Listen to me, please. This is a term to write down. Right? Primary key. A primary key is a simple idea. I don't know exactly why they gave it the name primary key. Maybe they should have called it something different. A primary key is a very simple idea. It guarantees uniqueness. When you mark something as a primary key, the whole purpose of that column is to make sure that no two students are identical. Remember, normalized databases are really good about storing our data, so we're not going to store duplicate data. Duplicate data is bad. That was really the major benefit. Like, I want you to imagine like an Excel spreadsheet storing like purchase information, and you're storing like customer name and customer address and credit card information. And every time that customer makes a purchase, you have to fill out that entire, what is your customer name? What is your address? What is your credit card information? You would store that information repetitively so many times. Okay? That's the benefit of normalized databases. We're not going to repetitively store information. Okay? Back to primary keys. Primary keys uniquely identify each student. This is going to be really critical this semester. You guys have to understand what a primary key is. We're going to be working with this from the jump start, right? Really early. So what is a good value for a primary key? Like, what would be a good example to make sure that every student is unique? How would you make sure that every new student you put into the database is unique? What would you do? What values would you put in here? Okay, that is very commonly answered. Very common. Understand why you say that. Why do you say that? That makes sense. Why do you say that? Everyone has a unique social. So I agree with you that that would be a good value, being that every student has a unique social. Okay. Now, why might that be not a good idea? Secure, right? Because database administrators, now when I see all my students, I have a list of all their socials. That's kind of a security risk, right? So I agree with you that, yeah, socials are unique numbers for every person, right? But that's probably not the best thing to do for security purposes. What else? What else would be a good value for a primary key? Yeah. Okay, a generated ID. Like what?
Like nano ID.
Nano ID. Okay. That is the ultimate answer I was looking for, right? But you skipped a step, right? Because I was expecting that answer, that is the answer that I would like to hear. But there's a middle step. What else have we done? We'll even put it this way. We've done another thing. Object IDs, whether it's a nano ID or an object ID, those are both referred to as GUIDs, right? Globally unique identifier. The odds of getting two GUIDs that are the same are like non-existent or very low. Okay, but what else have we done for primary keys that's not a GUID and it's not a social? What else have we done? Yeah. Email, could you use email? That's not an answer. You think I would have thought about that? I haven't really thought about email.
Assuming you don't allow more than one.
Maybe, and you know what I have seen, like phone numbers. Like you don't want, what does Netflix and what do Google do now when they want to make sure that you're not signing up for multiple free trials? They validate you by your phone number, right? That kind of thing. But another very common answer here is auto-incrementing columns. Auto-incrementing numbers, I should say. Auto-incrementing numbers, right? So your first customer is customer 1. Your second customer is 2, 3, 4, 5. Start at 1, increment by 1. Therefore, every new student is unique. See what I'm saying? You got student number 1, student number 2, student number 3, student number 4. Auto-incrementing numbers are common, but they're not the best answer. GUIDs are the best answer. And the reason, kind of like Social Security, is like, yeah, you could use Social Security. You probably could use email. You probably could use auto-incrementing numbers. But also, that could be telling. Like, let's just say, like, you're auto-incrementing people's bank account numbers, right? Well, your bank account number 1, you're number 2, you're number 3. I could probably guess what's next, Or another example is like, hey, we're all in competition. We're all making the same widgets, and your company has customer number 500. Oh, well, I know how many customers you have, right? And I have now information about your customer, about how successful you are, right? So auto-incrementing numbers are also not a really good idea for that reason, okay? Point is, we want to use GUIDs. We do use auto-incrementing numbers. And I would say GUIDs are kind of like the best answer, but, frankly, auto-incrementing numbers are commonly used. Okay? Now, to keep it simple there, if I would go over here to course, and I would just kind of do the same thing with this, I'm going to say, okay, students have a course, and this is going to be an underscore ID for the course. It's going to be private. And it is going to be an integer data type. This is going to be underscore, like a course name, which is going to be a string. Of course, there's like a course number, which is also a string. Something like that. And, okay. Okay, and the next thing I want to show you is that, hey, what do we essentially have here? Again, this is a many-to-many relationship, and this is no good. So you delete this. Now, okay. The 1 in the one-to-many represents the table with the primary key. The many introduces the table with the foreign key. So we talked about primary keys. We need to talk about foreign keys. We haven't talked about foreign keys yet. Okay, so if you're hopefully following along, like that's a new term. We're going to define it here in a little bit. Probably just delete whatever this is over here. I don't need you anymore. Okay. You know, and frankly, you know, this whole thing is a many to many. You know, how you draw that, and, you know, again, it could be drawn in different ways, but you have a many to many, and that needs to be broken up. When you have a one to many, the one represents where the primary key is located. The many represents where the foreign key is located. And so I'm going to delete this line altogether. And what I'm going to show here is a new table. I'm going to introduce a new table, and this is going to be called student course. Clearly, you combine the names of these two tables together. And what I'm going to create here is two fields that represent foreign key values. I'm going to have a private field that is the student ID and is an int. I'm going to have another field, which we can do underscore student ID. I'm going to create another field that is the course ID, which is an int. And now, this is called a join table. And it kind of has a couple different names. But we'll call it a join table. Let me think. Hold on. So as I kind of threw that term, it is a join table, is one way it's referred to. But you're also going to hear this, and actually there's student and there's student course, just as I'm doing in this example. Another table is junction table that breaks up a many to many. Another one is an intermediate table or a linking table or an associative table. It goes by a lot of names, which is why I'm like, well, potato, potato. I call it a join table, but you can call it what you will. Okay? And what this builds as I get my lines back is this line now is connected to student to here. And you create a one to many here. One to many between this table. And you create the same thing on this side. I'm going to paste that. And this says a 0 to many, but it needs to be a 1 to many here to a 1 to many here. Okay, so this is what I'm going to create, and the whole database design is based on this concept of like one-to-one manys are fine. You don't have to do anything with them. One-to-one are fine. One-to-many are fine. Many-to-many need to be broken up, and that's the quick version of it. How you break up many-to-manys is by introducing this new table, okay, where you have again, what does the 1 represent? The 1 represents the primary key table, okay? The many represents where the foreign key table is. So in student course, there is a column called student ID. That column is a foreign key column. So again, if you guys are taking notes, zone back in for me. Zone back in. We clearly identified primary keys. Someone remind me, what is a primary key? What's his job? What's the job of a primary key? Uniquely identify each entity, right? Good. Good. Foreign keys make sure, okay, and I'm going to have to think about exactly how to like say this succinctly, right? But foreign keys make sure that your entities exist in the primary key column. So it's referential integrity. In other words, you cannot put a student ID in my student course table unless that student ID first exists in the student table. Okay? Referential integrity is the fancy way of saying you cannot enroll a student in a course unless the student exists first. Right? Let's just say I have 10 students. Their IDs are 1 through 10. Student course is the actual, like, student number 1 is enrolled in course number 1. Course number 1 is whatever, right? This course or that course, okay? Referential integrity says, hey, I can't put a student 15 enrolled into a course because there is no student 15, okay? So foreign keys enforce referential integrity of the data. You cannot have a student 15 enrolled in a course if there is no student 15. Does that make sense? I don't know how to say that like more condensed. But primary keys, if you guys get these few concepts down, I promise you this is what you need to know for these database systems. Like, these are the basics of creating normalized databases. If you're going to create what's referred to as a normalized database, you have to make sure that your tables have primary keys. You have to make sure that there's referential integrity, right? That's primary and foreign keys. Like, that's pretty much, I mean, there's a bunch of rules, but those are the big ones. Yes?
So before you made student course, the normal ID in student, that was the primary key, right? Yeah,
that's still the primary key. The underscore ID is still the primary key. This is the primary key of the student table. Underscore ID is the primary key of the course table. And over here, we're going to see how we do this, but these are both foreign key values.
Okay, I had them flip-flop, sorry.
Yeah, these are the foreign key values inside of student course. Yes?
So if student course had its own underscore ID, would that be the primary key?
Okay. That if it had its own underscore ID, correct. Now, what's actually more common is you combine these two foreign keys, and those two combined together are the primary key. In other words, student number 1 cannot enroll in course number 1 more than once, so that those two columns together become the primary key for that table. Okay? And we're going to do that. Okay? So it's kind of confusing because these two foreign key columns combine a combined foreign key. A combined primary key. Okay? To guarantee that these two columns together, their two values, enforce uniqueness in this table. Okay? So let's do this. I'm going to build this now, right? So all that theory is cool, but let's make it practical, right? Let's build. And so we're going to be focusing in Microsoft SQL Server. The version is called LocalDB. Okay, so Microsoft SQL Server has a bunch of versions. The free version is called LocalDB, and that kind of comes free with Visual Studio. Okay, so what I'm going to do is I'm going to open up any project in here. It doesn't really matter. I just need to get to this screen where I can look at some of my windows. Okay, because when I look at my SQL Server Object Explorer, I see my SQL Server that's here, that's running on my machine, and I see these instances of SQL Server. Okay, this is kind of to say, like, this is the software that's running my database, and LocalDB is the free software that comes with Visual Studio. So when I expand this and I expand databases, I can kind of see I've got one database sitting here, and that's all that I've got. Okay, so I'm just going to go ahead and in here add a new database. So if you want to follow along, you just need to open up any project or solution. It doesn't really matter, because what I need to get to, I'm going to minimize this. You need to get to this Object Explorer, and if that's not there, it's under View. And here's SQL Server Object Explorer. Okay, there's also a Database Explorer. There's a Solution Explorer. Let me see. Here's a Server Explorer. I'm going to open up, I said Database Explorer. It's a Server Explorer. I'm going to open up this one as well. So I've got these two kind of tabs over here. But the Object Explorer, I think I'm going to be able to do everything I need. Okay. So the first thing you have to do is create the database itself on LocalDB. And I'm just going to add a new database this way. This is essentially creating the file. The extension, by the way, is a .mdb. So if you see, or MDF, not MDB, MDF. And so if I say this is my Rankin database name, this is going to create a Rankin.mdf file that is where everything is ultimately going to be stored. Okay, and then if you want to change the location, I wouldn't. But let's just go ahead and create our Rankin database. Okay, so now I've got the file created, and here you can see we've got no tables. Okay, so now because I've done a little bit of UML diagramming, I can see I've got 3 tables that are going to go into my database. These tables have primary keys, they have foreign keys, and they're going to have a compound primary key in this. They have a join table. Okay. Okay. So let's go ahead and create student first. It's our first table. So I'm going to right click, add new table. Now the first thing to realize is that you can do this with structured query language. And so if you're versed with SQL, you can say, okay, create table. This is called the schema DBO, which is kind of like the permissions. I view this as the permissions. The database owner can get to this table name. And so really, this is the table name student. The underscore ID is an int. I'm not allowing nulls, and it is the primary key. Right? And so if you're versed with SQL, you can definitely write a little bit of SQL code. This is by the way, this is a version of SQL called Transact SQL, T-SQL for short. Transact SQL, this is the Microsoft version of SQL. SQL itself is a standard. It has a couple of different versions. Microsoft's version is T-SQL. Oracle SQL is called PL SQL. There's syntactical differences, but ultimately they're both SQL. Okay. Now, probably for this class, instead of having to learn all the SQL, you could also use this designer, right? This designer right here, you know, we can right click and remove primary keys, set primary keys. Okay, now if I kind of don't like, that's kind of interesting. Keeping these two synced up, I'm just going to say underscore ID. Okay, so this is pretty much what I typed. Now it broke my table name, student. I think because I was alternating back and forth, I was like losing sync between the two. And so now you can see DBO dot student. And if I were to save this, it's going to save a .SQL. It's going to save my T-SQL. But that doesn't actually save, it doesn't actually create the table. It doesn't run this command to create the table. To actually run this command, you just have to click this update button. Okay? So when you click save, a lot of beginners make that mistake and think, oh, if I save this, then I'm actually creating the table. No, you're not saving the table. You are simply saving a file with the transact SQL in here. That when you run this command, that creates the table. Okay. We also had a given name, which we said was a string. By the way, SQL Server doesn't have strings, right? Take a look at this. We don't have the string data type. Okay. In SQL Server, the equivalent data type is a varchar. And let's talk about varchar 50 versus varchar max. Okay, well, first off, what is a varchar? A varchar is a variable length character. A string. Variable length characters. How many characters can you have? Well, if you say varchar 50, how many characters do you think you can have? There you go.
Can you put a lower number? Or
Yeah, you can say varchar 2. IL for Illinois, right? Data types in SQL Server do not match data types in C#. SQL is its own independent language. They have their own data types. Okay, so on the database side, we've got varchars. In C#, we've got strings. You pull the data out of SQL Server and store it in a string if it's a varchar. Okay? But converting between data types is something we're familiar with, right? You have to know. But varchars just come right out and store a string, no conversion needed. Okay? Now a given name, how many? I don't know. Is 50 reasonable for given name? Sure. Let's just say in our system you can't have a given name more than 50 characters. That makes sense to me, and I do not want to allow nulls, right? Little checkbox to allow nulls or not allow nulls. Okay, and family name, we'll say varchar 50, and also do not allow nulls. Now, just kind of glancing at the other data types, you know, nchar versus varchar. Okay, nchar is 8 bits for every character. In other words, ASCII, if you guys were familiar with the ASCII system. Okay, if you're working with old software, you might be working with 8 bits for every character. But most modern software actually take 16 bits for every character. That's the difference between nchar and varchar. Varchar, varchar just means, excuse me, let me correct myself. Hold on. There should be a char 50. There it is. Okay. What do you think the difference between char 10 and varchar 10? Sorry?
just want a lot more characters?
Same, 10 characters.
I mean, like different types, like letters, numbers.
Nope, good guess. Char means 10 bytes of storage every single time. So if you fill up my 10 characters, we are using 10 characters, no matter what. If you only give me 2 characters, I'm still taking the space of 10. Right? So what's better? Char or varchar? Varchar. Varchar. Right? Because variable length, okay, it can go up to 10, but if you only give me 2, I'm only going to reserve 2. Right? So it's just more efficient storage. Varchar, always more efficient than char. Okay. There's a third one. And I'm just going to say street and varchar. Oh my gosh. Okay. This nvarchar versus varchar. Okay, so let's just talk about varchar 50 versus nvarchar 50. Nvarchar stores 2 bytes of storage for every 1 character, aka Unicode, aka everything since the 90s has been on Unicode. Varchar is 1 byte for every character, 1 byte of storage for every character, aka ASCII, aka way old stuff. Okay? So, really the most flexible thing for a string that we have is nvarchar 50. And so that's a long answer about data types, but all of this, nvarchar, I'll say nvarchar, nvarchar, and then I don't really care for a street, so I'm just going to delete that. Okay. Okay, so here's a real simple table with simple data types. And let's click the update command. And let's click on update database. And you get this green check mark, which is a good thing. You go back into your Object Explorer and you click the refresh button. And you see that our Rankin database has opened it up, so I'm going to close. So let's go back in here, try again. And there's our student table. Okay. Now DBO is what I referred to as a schema. And for the most part, it's always going to be DBO for these simple projects that we're doing. But the way this could work is that you could have different like permissions. And so you could say HR has access to these tables. Developers have access to those tables. DB database administrators have access to everything. And so you can kind of break up permissions with this prefix that's in front of the table name. But, you know, for our needs and purposes, everything's going to be DBO. Like we're the database owner, we're going to have access to everything. Okay? Now let's go ahead and if I view the data, again, you could use I say one given name is Evan Gudmested tab, and now I've inserted my first row. Of course, you could use an insert SQL statement to do just the same thing, or you could use the GUI. Quite simple to go ahead and do this. Okay. Now, an easy way to set up. Let me just say, this should throw me an error. And there you see, it's like, hey, you can't do this, and you should know why, right? The ID is duplicate. That's not unique. It's a primary key column. That's a problem. And so I could do this, and that'll work. Because, well, there can be a whole bunch of John Smiths. There can be a whole bunch, in theory, of Evan Gudmesteds, although I've never met another one. Although if I were to go to Norway, I bet you I would. Okay. One more thing that's pretty common to do is set up this as an auto-incrementing column. So Mongo was great because it would automatically create object IDs for us, right? And that's really the superior way to do it. Again, that's my preference for Mongo. Get out of my face. Let me just delete my data. And close this. Now, after the fact, I'm like, oh man, I created this table, but it wasn't done. I wanted to do something more. I can make changes to the table design by viewing the designer. And I'm back in this view, right? Because I forgot something. And so I can just open up the design view and make changes. What I'm going to do here, I'm going to click on the properties of the ID column. And you can go down to here on, now I have this properties column and set identity to true. Seed the data at number 1 and increment by 1. Right, so what I did is I right clicked here. I clicked on properties. I right clicked the ID column. And then I expanded the identity specifications in the properties window. I right-clicked the table and I clicked View Designer.
Oh,
okay. So then I right-click ID and I go to Properties. I set it up as Identity. it is when you say it's identity, it's kind of like saying it is the primary key. But what we're doing here, back in the properties window, is we're saying, yeah, this is the primary key column. It's the identity column. We're going to seed the data at 1, increment it by 1. And then I'm going to click on Update. And it says tables will be recreated with the data migrated. So I'm going to click on Update Table. I get the check marks. Okay, now my ID should auto-increment. I shouldn't have to plug in an ID. It should just do it for me. Yeah.
I have 2 questions.
Please.
One, is it always false by default?
Yes.
Okay. And then do you ever change the numbers?
You're welcome to, but not necessary. You can change the numbers. Again, if it's, predictable to go up by 1 every time, maybe you say go up by 3. Okay, I'm also going to say it can kind of be buggy. Like if I view my data and I can just now put in Evan Gudmestead and I tab and notice, okay, it went to 1. And I'll put my brother in here. Okay, so I guess it's not being buggy, but I've seen that, like, hey, you should just start at 1 and go up by 1. I've seen that bug out. Like, why are you at number 5 all of a sudden? But it doesn't really matter. It's just, as long as it's unique, that's all that matters. Yeah.
Dumb question. With us constantly getting updates and everything, because this is just like from the SQL server and everything we opened up so brand new file, we should still be hitting the save.
Okay, what was the difference between update and save? Save the transact SQL, and then update executes the transact SQL. So it's literally a difference between source code, saving the source code, or executing the source code. Okay, so do you want to say, I didn't save my source code.
So if we close
I never once saved my source code because, yeah, you can close it and reopen it. And if I go back to View Designer, it's still there in its current form.
Okay, so it doesn't go away.
Yeah.
Close Visual Studio.
Yeah, I didn't lose it. So I never had, yeah, you can close Visual Studio, reopen it, and it'll still be there. Yeah.
That's what I was wondering.
Yeah. Yeah, it's going to kind of write it's going to kind of write what it currently is. And again, I just noticed it now says identity 1-1 not null. But again, that is your primary key column. It's literally the keys right there. Okay? So let's do the same thing for our next table, except for let's not forget the step. I'm going to create a new table. So under table, right click, add new table. This is going to be course. So I almost have to. I don't think there's another way to do it. I think you have to do right here. And then I'm going to go back up here. Underscore ID was our convention. It is an int. I'm also going to go to its properties to set it as identity. I'm going to change this false to true. And it is going to be 1 and 1. I'm cool with that. I said course ID is an int, not allow nulls. And course name is an int. And then I do not allow nulls. And I'm going to click on update. And I'm going to update the database. Okay, we've created my next table. No relationships yet between tables. No relationships between tables. There are no lines drawn because our tables are not linked together. The lines are the links between tables. They set up primary key and those foreign keys. Okay, in fact, I might even do a fourth table here just to show a simple one-to-many relationship. Oh, thank you. So I made a mistake, and it was course number. Thank you. Underscore course, and I probably just said underscore number, yeah?
Yeah.
Underscore number and underscore name. And so I'm going to rename my column. These are my column names, by the way. I always thought it was funny that in our designer, we're naming our columns in rows. Like this is the ID column, but we're creating it in a row. That's just the way my weird brain works. Don't let it confuse you.
Name int in your UML?
Let's not do that. So let's make name. That's what happens when you don't think about it. We're going to do nvar char max and number. Sure, we'll make it an int. Even though, like, if I think about ranking courses, yeah, it's like AWD 1115. Whatever, we'll just make it 1115. Okay, so now I'm going to click on update, and if I update the database, okay. So what I'm going to do in here, in my courses, I'm going to view the data, and the ID should be auto-incrementing. So my number is 1000, and Web Development Fundamentals is the name. Number 1100, C# Fundamentals. Then there's all ones, which is our MERN stack. And then there's 1115, which is .NET stack. Okay? So we've got 3 students, we've got 4 courses. Now we get to enroll courses in students. We get to enroll students in courses. Jeez. Okay. There's our databases, there's our ranking database, there's our tables, there's our course, there's our student. My first course. See, you remember how I said it was just kind of buggy? It does that.
I went to give names to the students, and my ID number is 3, 5, and 6.
There you go.
So how do I fix that?
Yeah, you just leave it.
We leave it at 3,
Yeah.
5, and 6.
Sure.
You got
It's annoying, but I would leave it.
You're so true, Tom.
Yeah, I'm guessing the index using the increment screws up when like deleting stuff.
Yes. Yes, that's right. So now I need to make that join table. And going back to the UML, so I made a student ID and a course ID in a table called student course. So let's create a student course, add a new table. This is student course. Okay. Now, okay, student has an underscore ID that's a primary key. In this table, student course, the first column is student ID that's going to link to our underscore ID in the student table. A common thing here is like Mr. G, should those identifiers be the exact same? I think for readability purposes, that's a good idea, but they don't have to be, and in many cases, they're not. They link together. But the point that I want to make here is that these two columns will link together, but the column names do not have to match. Should they match? Yeah, it makes sense, I think. But they don't have to. So the fact that we called it underscore ID over here, which represents the student ID in the student table, and in the student course table, we're going to call it student ID. It's not underscore ID, it's student ID. That's okay. Okay, the identifiers don't have to match, although it kind of just makes sense. But that's not the road that we're going down. Hi, Miss Stacy. Okay. So now that I'm creating student course, I actually don't want that as its primary key, and I'll show you why. I'm going to create underscore student ID, and I'm going to create underscore course ID, which is also an int, and it does not allow nulls. And I mentioned this earlier, we can make what's called a compound primary key, where 2 columns values come together to set them both as the primary key. So now the two values together are enforcing uniqueness.
You do that in one click.
I hold down, what I did is I held down shift and I clicked them both, and then I right clicked and set primary key. Okay? So now in this table, these two columns together are the primary key, but there are no relationships between the tables yet. I need to set up my foreign keys. See this right here? No foreign keys. I need to create a foreign key. Again, if you know SQL, it's not that hard to create a foreign key with transact SQL. Okay, but it's even easier to create it using a GUI. Okay, so again, you can kind of come down into here and create foreign key relationships between tables with SQL, transact SQL. But it's even easier using the GUI. So what I want to point out right now is that right now in our database, we've got 3 tables, but there's no links between the tables. There's no relationships between the tables. We now need to create this one-to-many from student and to create a one-to-many from course. Okay, so let's do that. I'm going to create a foreign key, add new foreign key. And you see the properties here. Now, let's kind of look at this. Okay, so this is going to be foreign key. Let me think if I want to create it from here or from the other table. Okay, no, I don't. I'm actually going to delete this foreign key right here. I'm going to create it from my student. Okay, so I just delete that foreign key. I'm gonna keep this just like this. Apologies for that. I want to create my foreign key base table from the student table or the course table. So I'm gonna click on update at this point. I'm gonna click update database. Okay. So now, if I go into here, I see my 3 tables, but there are no links between them. I'm going to go back into student, view my designer. I'm going to create my foreign key here. Now notice this is foreign key student to table. So we don't know what tables we're linking together. But you can name this. This is just the name of the foreign key to student course. So this will be foreign key student as the primary key table to student course. So I will say to student course. So where is the primary key, which is in student, to the foreign key table, which is student course. And it looks like, I'm sure there's a way to do it through the GUI, but at this point, I like the SQL that it gave me. So here I'm creating a constraint, a foreign key constraint called this foreign key underscore ID, which is this table underscore ID, references student course. What is the column there called? I think we called it underscore student ID. So this is creating a foreign key constraint where the primary key is ID in this table, references and you know what? I got that completely backwards because here I had it right the first time. References student course Yep, I got that backwards. Undo. I'm just going to delete that and close this. Don't save. My bad. Student course. We're going back into here. I had it right the first time. View designer. Add a foreign key. Student course to student. Constraint, foreign key, student course to student. Foreign key is underscore student ID. References student table underscore ID. There we go. I had it right the first time. So this is student course to student. Let's create one more. Add new foreign key. Student course to course. This is the foreign key column, which is underscore course ID. If you don't do it every day, you make these little mistakes. Course underscore ID. And that all resolves. Now we've linked the tables together. Apologies for my mistake there, but it should be resolved. And now if I click on update, these foreign key rules should go into place. Again, this foreign key column, which is student ID, references the ID column in the student table. And this foreign key of course ID in this table references course underscore ID, of course, in the course table. Okay? Did I lose you along the way? Eh?
I'm still here.
Are you following the theory?
I'm going along with you.
Does it make sense?
So far.
Okay. Yes.
Can you go to the student?
I can. Let me run this update database, and make sure that I got my green check marks. Okay. Now, can I go to the student? Okay.
I just had a question.
Yes.
So you had like 50 characters, right? What happens if you have a student name that has all 50, but then you change it to something lower? Will that like screw things up?
No.
It'll keep the 50?
So you're saying, what if you run an update on the data, right?
Yeah, so like if a kid had a 50-letter name and
Yep.
then you changed it to 20 characters only?
Yeah, not a problem.
Okay.
It can handle that. Absolutely. Okay, so what we have currently is we have data in our courses. If I view the data, I've got 4 courses. We have data in students. I've got 3 students. They have IDs 1, 2, and 3. My courses have IDs of 1, 2, 3, and 4. So how do I take student number 1 and enroll them in course number 1? To enroll student number 1 in course number 1, I do that right here. The student ID of 1, that's me, is enrolled in course ID of 1. That is Web Development Fundamentals. Also, student ID of 1, Evan, enrolls in course ID of 2. Evan enrolls in course ID of 3. Evan enrolls in course ID of 4. Let's say Evan enrolls in course ID 5. We get an error. Why? There is no course number 5. Foreign key constraint says, hey, there is no course ID 5. You can't insert that data. That's not possible. Yeah? Impressive? No? Woohoo. Student number 2, that's my brother. He enrolls in 1. My brother also enrolls in 2. My dad enrolls in 1. Okay. In the database, what the heck does it mean for ID 1 and course ID 1? No end user will ever see those IDs. What do we do for end users? We query this data using SQL and we show student ID 1 the courses that they're enrolled in. What was that command to bring the data back together? Because right now our data is kind of stored in different tables.
Group.
Not group. Nah. Who said it? Yeah, join. Right?
Synonyms.
Joins are how we take the data that's stored in different tables and we bring them back together. So a lot of what we're doing in this normalization process is we're breaking the data out across all these different tables. And then we have to join the data back together for our applications to say, okay, student number 1 is logged in. What courses are they enrolled in? So we have to run SQL join commands to actually make the data relevant. Because no end user knows their student ID or course ID of 1. No one knows that. That's not relevant. You gotta extract the relevant data. But now you understand a little bit around, hey, I've got some referential integrity behind my data because I don't have a student ID of 4 or a course ID of 5. That's not allowed. You with me there? And now I've created a normalized database with primary keys, foreign keys, and, I love the word data anomalies. You hear me say that all the time. Data anomalies is a fancy word for problems with the data. These systems are very strict, and so they're good at getting you clean data. And that's important, right? That is a benefit in many cases. If you have a normalized database, like that helps you get good, clean data. And data out of a system is only as good as data into a system, right? Crap data in means crap data out. Good data in means good data out. So it's, important, it's imperative even, that we put good data into our systems. So that's your benefit of that. Now, again, all these concepts, primary keys, foreign keys, all these data types, all this stuff, we're going to use this all semester. But this is the review that I wanted to do, and I hope you guys found it useful. Do you guys have any other questions about these basics?
So when we want to associate them to each other, we always have to create a new row in the student course or whatever the join table is.
Yeah, when you want to set up a foreign key, you do so, and I did a mistake because I was trying to set up a foreign key from the primary key table. You set up the foreign key from the foreign key table. Now let's do one that's not a many-to-many. I think that might be a good finish here. It's like say, hey, a student can have many. Let me think. A student can have many books. I don't know, just making up. A student can have many books, but a book can only have one student. Okay? So I'm going to create a relationship between student and books, and it's not a many-to-many, right? So if I were to just kind of throw that up here, a student can have many books, but a book can only have one student. So I'm just going to create a one-to-many, and I'll just throw this on here, and this is going to be book, and I would say that the book has an underscore ID, which is an int, and a book has an underscore name, which now that we're talking SQL Server data types, we know envar, char, max is a very flexible data type. Max means there's no upper bounds. It could be up to as many as you want. It could be as low as you want. It's dynamic in sizing, so it's a very flexible type. And the type here is not a many-to-many. It is a very simple one-to-many. So it's kind of like one-to-many. This way, one-to-many. A student can have many books, but a book can only have one student. And so it's going to be something like that. And now I would do this again, and I would say add a new table. Again, the one represents where the primary key is. The many represents where the foreign key is. I think that's a good thing to remember. The one represents where the primary key is. The many represents where the foreign key is. So I'm going to create a table called book. The book has an underscore ID. It is int. It is the primary key. And it has an underscore name and varchar of max. It also does not allow nulls. Pretty simple table. Let's update it. Let's update the database. We now have a book, but that book has no relationship to our other tables. Okay, that's it's out on its own island. I think they call it an orphan table. It's just out on its own. Maybe that's not 2024 politically correct. I don't know. But the point is, there's no relationships between book and anything. So it's out on its own island. It's kind of hanging out by itself. And let me see here. Sometimes, no. If this were actually SQL Server, you could get this UML with all the lines between them in a diagram. There's a tool in Microsoft SQL Server to generate a database diagram. Let me see if I can data compare. I don't think they have that inside of this tool that I'm using. Not super important. But by the way, I can kind of see if I look at my keys on my courses, I can see these just have primary keys. I see this has a primary key and 2 foreign keys. You can see the columns and all their data types. But if I go to keys here in my book, I just have a primary key, nothing else. So a book, a student has many books. So what am I doing here? So book, view designer, slow that down. Let's see. New foreign key. Book to student. Book to student. This student ID is also an int. So when I create a book, the book is going to have an ID, a name, and who that book belongs to. Essentially the student ID that book belongs to. And so just to flush this out, so now here's my foreign key book to student. Foreign key is my underscore student ID. References book student underscore ID. And that resolves, and I now have a foreign key column inside of my book. And if I update that, update the database, bunch of green check marks. And if I go to my book column and view data, again, is this the perfect database design? Maybe. So the book ID should be auto. I didn't set that up to auto increment, did I? So I don't think I did. But the book name is, .NET Core. And just to show that the student ID of 1, that's valid, here .NET. So this book could have a student ID of 2. The data in row 2 error, violation of primary key column 2. There we go. Primary key column 3, .NET Core. The database design, actually I don't like this design, but I am demonstrating a one-to-many relationship. Primary key .NET Core. Again, this is not perfect data because I'm storing the name of the book multiple times. That's the problem that I have with this. But the student ID of 4, that student doesn't exist, so that's where you encounter your one-to-many relationship problem. So that's just where you don't need that join table. You can have a simple one-to-many relationship, and I demonstrated how to do that. Okay, we'll stop that there.